Alright, looking at this page in your star push packet, it would probably be about page 10. And as the first question says, which of the following best describes a neutron? Alright, if we look at A, it says a positive subatomic particle. So we can automatically, if I were doing this on my own, I would probably put an X through positive because that tells me that's wrong. We know neutrons don't have a positive charge. B says negative subatomic particle that moves around a cloud. Well, I know it doesn't have a negative charge either, so I can go ahead and cross through negative. If you look at D, it says negative charge once again, so I can cross through that. Get in the habit of doing that as you're taking your test, and it'll help you out. So your only answer choice left would be C, which is a neutral subatomic particle located within the nucleus. That would be your correct answer. Number 2 says an atom has 24 protons, 28 neutrons, and 24 electrons. Remember, your protons and electrons are always going to be the same. What is the charge of the atom's nucleus? Key word here. It didn't ask for the overall charge of the atom because, of course, your protons and electrons would cancel out, so your overall charge would be 0. But it asks what is the charge of the nucleus. Well, in the nucleus, I draw it out. We only have protons and neutrons. So protons have a positive charge, neutrons don't have a charge. That means your charge of your nucleus is automatically positive. And so we can rule out the negative answer choices. And those positive charges are from your protons. So we had 24 protons. So your answer should be J, 24. Number 3 says, which information on the periodic table gives you the number of protons of an element? A says the atomic mass. Well, the atomic mass doesn't give you the atomic number, or doesn't give you the number of protons. It doesn't give you the number of electrons. It simply gives you the mass of the element, which is your protons and neutrons combined. Your symbol just tells you the symbol of the element, and then your name just gives you the element name. So the only one left is your atomic number. Remember to write 8-man on your test booklet, and you'd know that because the 8th part of 8-man stands for atomic number is equal to your protons, which is also equal to your electrons. So your answer to number 3 should have been B. Number 4 says, which of these best describes one of the subatomic particles that could be found at location X in the model of the atom shown above? If we look at answer choice G, it says it has no mass and a positive charge. Remember, we're looking inside the nucleus. Alright, so only 2 particles exist inside the nucleus. So I would write nucleus. What's in that nucleus? Your protons and your neutrons. Alright, I know protons have a positive charge. I know that neutrons don't have a charge. I know that protons weigh 1 AMU. Neutrons also weigh 1 AMU because they have the same weight. So then we look at our answer choices. Alright. G says it has no mass and a positive charge. Well, your proton has a mass and it has a positive charge. So it can't be that because it says has no mass. So we can put an X through that because no mass. Everything in the nucleus has a mass. H says it has a large mass and a negative charge. Well, there's nothing in the nucleus with a negative charge. Your electrons have a negative charge and they're out here on the outer rings. J says it has no mass and an equal number of positive and negative charges. Well, we just talked about both of the particles, subatomic particles in the nucleus have a mass, so that would automatically eliminate that. Also with the negative charges, it would eliminate that answer. So your only logical answer choice left is it has a mass but no charge. Remember, they're not asking for both of the particles inside of the nucleus, they're only asking for one, and that one would be your neutron. It has a mass but no charge. That's why your answer is F. Alright, looking at page 11 in your star push booklet. It says the periodic table is arranged left to right according to its atomic mass. Number 2, elements that have the same number of energy levels will be in the same period is what it should say. I put group, that should be period. good to double check yourself, because your period number tells you your number of energy levels or valency. Your number of energy levels or energy rings, as some people call it. Some people call it energy shells. So you may hear energy levels, energy shells, or energy rings. Number 3, reactivity of an element is determined by its valence, electrons. Which group is stable? Well, we know that group 18 is stable because it's your noble gases. The reason it is stable is because it has 8 valence electrons, all of them except helium, which has 2 valence electrons. But the main gist of it is their outer energy shell, or their valence shell, has a full shell, and so therefore they can't take on anymore, so it won't be reactive. So it is considered to be stable. Number 5. Why is helium stable with only 2 valence electrons? I just answered that one. Because it can only hold 2. If you look at it, draw you one ring, which is what helium is, one ring, because it's in period 1. It has 2 electrons. Well, since this is your outermost shell, because there's only one ring, it's full, because that first level can only hold 2 electrons. That's why it is stable with only 2 valence electrons. Describe group 18's properties. They are gases. They're not good conductors of heat or electricity. Alright? Most of them are odorless and colorless. Number 7, name 2 elements in the same period. Well, in the same period, you're reading across, so hydrogen and helium would be in the same period. Anything across this next row would be considered in the same period. And everything across the third row would be considered the same period. Alright, so when you talk about periods, you're looking across to make sure they're in the same row. Moving on to page 12, looking at the top. It says an atom of an element in period 4, group 2 of the periodic table, has electrons in how many energy levels? I underline period 4 because that's going to be very important. And then energy levels. Remember, your period tells you how many energy levels you're going to use. So if I have a period 4, that means I'm going to have 4 energy levels. Pretty cut, dry, and simple there. Number 2, fluorine, a member of group 17. I underline group 17 because it's always going to be important. Has an atomic number of 9. How many valence electrons does it typically contain? Alright, remember, to figure out the valence electrons, you can look at the group number. Cover up the 1 on those that are 13, 14, 15, 16, 17, and 18, and look at the remaining number, and that would be your amount of valence electrons. So if I cover up the 1 on group 17, that leaves me with 7. It tells me that I have 7 valence electrons for fluorine. Number 3 says an element found in group 2 of the periodic table would contain how many valence electrons? Again, you just look at that number. Since it's group 2, that means it's going to contain 2 valence electrons. Number 4, the element fluorine, chlorine, bromine, and iodine are all found in the same group, 17 on the table. These elements are grouped together because they, alright, remember, everything in one group, in the same group, all react the same. Alright, because they have the same number of valence electrons. So group together is going to tell you to hone in on your groups. So your answer would be H, react in similar ways. Number 5, which statement explains why noble gases do not react naturally with other elements? Alright, I put on there do not react naturally, because it's going to have something to do with the reacting of it. If I look at B, noble gases are stable because their valence electron shells are incomplete. Well, we know that's false because your noble gases all have full energy shells, so that makes them stable. If you look at C, noble gases are in the same period. Noble gases are in the same group, not period. They're in the same group, so that makes C wrong. We can cross that out. D says noble gases' physical properties are different than any other element. Alright, that's not true because you have some gases in group 17, just like your noble gases in group 18. And so that one would be false. Your only logical answer is noble gases are stable because their valence shells are complete. Alright, they all have 8 in their last shell, which makes it full, aside from helium, which has 2, but it only has 1 shell. So that one is full. So your answer choice is A for number 5. If you look at number 6, it says the table above shows the number of protons in an atom of 4 different elements. According to the periodic table, which of these elements is a metal? So your metals are going to be on the left side of your table. That only one on the left side of your table would be H, which is X. The way that I knew that is you look at your number of protons. Remember, your protons is also your atomic number. So that's telling you where exactly to look on the periodic table, because protons is the same number as your atomic number. Number 7, a model of an atom is shown below. Which element is represented by this model? They have an X here on purpose because they have one too many of this element here. A couple of ways you can determine this problem. You can count all of the things inside the nucleus, 1, 2, 3, 4, 5, 6, 7, and say, well, it has to be something that has an atomic mass of 7, which is D, lithium, when you look at your periodic table. Or you can count the electrons and say 1, 2, 3. There are 3 electrons, so there has to be 3 protons. 1, 2, 3. Those are protons because it's the same equal number as your electrons, which also tells you your group numbers. Your atomic number. So I look for something with the atomic number of 3, which would be D, lithium.